Okay, after loading the model file, the first thing that I need to do in order to use detailed HVAC is to open up the model options dialog and set the HVAC mode to detailed. I can do this by clicking on the spanner icon on the toolbar here. You'll notice under the HVAC header on the model options dialog there are three possible HVAC modes: simple, compact, and detailed. It's the detailed option that I need to select. So having selected the detailed HVAC mode, you should be able to see that an HVAC system node has now appeared in the navigator. If I click on this node, I'll be taken to the detailed HVAC edit screen. And this is where I can begin to assemble my HVAC system. You'll notice there are two new icons on the toolbar, an Add Zone Group icon and an Add Loop icon. I'm now going to place a generic air loop, which can be used for various configurations of constant and variable volume systems. So I'll select the Add Generic Single Duct Air Loop and just place it on the edit screen by clicking the mouse button. You'll notice a component at the top right of the loop with an arrow coming off it. This is a set point manager, and all predefined loops in DesignBuilder HVAC include one of these to set the supply subloop outlet temperature. In the case of an air loop, the temperature is scheduled to be always 14 degrees centigrade. So what I need to do is to add heating and cooling coils to the air handling unit to maintain this subloop outlet temperature. Okay, so first I need to step down to the air handling unit. I should mention that DesignBuilder HVAC uses the same decomposition level mechanism used by the building modeler and the same methods of moving up and down levels. So you can double click on the component graphic on the edit screen or select it from the navigator to move down to it. And to move up a level, you can either press the F2 key or select the parent object from the navigator. So I can select the air loop and double click on it to step down to the air loop level. The air loop is actually split into two subloops, as are all loops in DesignBuilder HVAC, a supply subloop and a demand subloop, which is the way that all HVAC loops in Energy Plus are constructed. The supply subloop is where energy is supplied to a loop, and the demand subloop is where energy is extracted from the loop. And in the case of an air loop, this demand would be presented by zone equipment. So I'll select the supply subloop and double-click on it to step down to it, and then select the air handling unit and double-click to step down to that. At this level, you'll see there are three new icons provided on the toolbar for adding a humidifier, cooling coil, and heating coil. If I click on the Add Cooling Coil tool, I can place a cooling coil in the air handling unit just by clicking the mouse when it's at the point where I want to position it. When you're adding components to an air handling unit, you can place them in front of the fan for a draw-through configuration, or after the fan for a blow-through configuration. I'm going to place the coil in front of the fan. Okay, I'll go through the same process to add a heating coil, which I'll place between the cooling coil and the supply fan. To edit component properties, for example the cooling coil, I can select the cooling coil and then right-click to access the edit menu. And you should now see the cooling coil dialog with all the various settings. I'm just going to change the type of the water cooling coil to a detailed geometry type, and I'll keep the other default settings. So I'll just OK that dialog. If I now move back up to the supply side subloop, you'll notice that the label under the air handling unit has CAV in brackets, which means that the air handling unit is actually a constant volume unit at the moment, And so for a VAV system, I'll need to change the fan type to variable volume. So I'll select the air handling unit and right-click to access the edit dialog. And I can now change the fan type from constant volume to variable volume. But while I'm here, I'll just point out some of the air handling unit settings that are available. You can opt to exclude the extract fan from the unit if you want to. There's a night cycle option which allows you to specify night cycle operation. Under the recirculation header, it's possible to switch recirculation off altogether if the system is a full fresh air system. Otherwise, there are outdoor air limit schedules, various economizer types, and I'm actually going to set the economizer to a fixed dry bulb in this case. There's an economizer override schedule and high humidity override. You can also include a heat recovery device, and lastly you can include preheat and pre-cool coils. But those are the only modifications I'm going to make. So I've changed the fan type to variable volume, and I've included a fixed dry bulb temperature economizer. Okay, so I'll just click on OK to keep the changes I've just made, and I'll now move back to the system level. Having placed the air loop, the next thing I need to do is to define zone HVAC equipment. Now, what we've done in DesignBuilder HVAC is to provide a zone group component to avoid having to define equipment and connections for a series of zones which have identical items of equipment but not necessarily the same equipment ratings. So, for example, you could add a number of zones to a zone group that are all served by convectors, but where each convector might have a different output. You can then add a single convector to one of the zones in the zone group, and this convector will be automatically added to all of the other zones in the group. And you can then change the rating for each convector on a zone-by-zone basis. Also, when you come to connect the zone convectors to a hot water loop, you only need to make one set of connections. For this system, I'm going to supply the ground floor zones using simple VAV boxes. And provide heating using convectors. So I'll click on the Add Zone Group tool and place one zone group for the ground floor zones to the right of the air loop here. The mid-floor is going to be supplied using VAV boxes with reheat coils, so I'll add a second zone group for the mid-floor zones. And finally, the top floor is to be conditioned using fan coil units. So I'll add a third zone group for the top floor zones. You'll notice that the zone groups have a light grey outline, and this means that they don't yet contain any building zones. So the next step is to add building zones to the zone groups. I'll now select and edit Zone Group 1. You'll see that the Zone Group dialog has 3 tabs. The first tab allows you to change the name of the zone group and to specify which zones to be included in the zone group. I'm going to change the name of this to ground floor zones. And then check the ground building block checkbox to add all of the ground floor zones to this group. But while I'm here, I'll just mention that the second tab allows you to set up heating and cooling priorities for zone equipment that would be added to the zone group later. There's also a zone defaults tab, which isn't actually hooked up properly yet, but will allow you to assign defaults to selected zones within the zone group. So I'm just going to OK that, that dialog now. So I'll now edit zone group 2. This time I'll change the name to mid-floor zones. And I'm going to add all of the mid-floor zones to this group by clicking on the mid-building block checkbox there. Okay, and lastly, I'll edit zone group 3. This time I'll change the name to top floor zones. And I'll add the top floor zones to this zone group. Like that. Okay. Okay, the next thing to do is to add zone equipment to the various zones. So I'll now move down to the zone level for the east zone in the ground floor zone group. Although it needn't be that particular zone, it could be any zone in the group that you add the equipment to. I want to add a simple VAV box to this zone. So I'll click on the Add Zone Air Distribution tool and then select the Single Duct Variable Air Volume Without Reheat option. And just click the mouse button when the cursor is over the zone to place the unit. You'll see that the unit is automatically positioned at the top left of the zone. I can then do the same thing to place a zone extract. Now heating for the ground floor zones is being provided by convectors. So I'll now click on the Add Zone Radiative Convective Unit tool and select Add Water Convector. And then I can place the convector in the zone in the same way. You'll see that the convector is automatically positioned on the floor on the floor of the zone. So having defined all the equipment for the ground floor zone group, I'll now go to one of the zones in the mid-floor zone group, which I can do using the navigator. For the mid-floor zones, I want to add VAV boxes with reheat coils. So again, I'll click on the Add Zone Air Distribution tool, and this time I'll select Single Duct Variable Air Volume with Reheat. And again, I need to add an extract unit. Lastly, I'm going to use fan coil units to condition the top floor zones. So I'll go to one of the zones in the top floor zone group, as before. And this time I'll click on the Add Zone Forced Air Units tool and select the Add Fan Coil Unit option from the drop menu and place that in the zone. And you can see that the fan coil unit's composed of these three subcomponents, a fan, a cooling coil, and a heating coil. I'm not going to edit those at the moment. I'll just keep the default settings. So that completes the zone equipment, and I'll go back to the system level. Okay, I've now defined the air loop, the zone groups and zone equipment. So now I need to add plant and condenser loops. The air system that I've put together incorporates both water heated equipment and water cooling coils. So I'll need to include hot and chilled water plant loops together with a condenser loop for heat rejection from the chillers. So first of all, I'll zoom out and pan to create some room to add the additional loops. And then I'll click on the Add Loop tool and select Add Chilled Water Plant Loop. And I'll place the chilled water plant loop above the air loop here. I'll then click on the Add Loop tool again, and this time I'm going to go for the hot water plant loop option. and I'll place the hot water plant loop to the right of the chilled water loop. And finally, I'll select a condenser loop and place it to the left of the chilled water loop. I'm going to allow some room between these two loops because I'm planning to add an additional chiller to the chilled water loop to demonstrate the plant operation scheme facility. Okay, Energy Plus includes a feature which allows you to define various plant operational schemes. The idea being that you can model scheduled sequencing of plant equipment depending on time-varying load requirements. For example, you may want to model a modular boiler system and schedule low-load modules to handle loads up to a certain magnitude, and then switch in more modules as the heating load increases. I'll demonstrate this feature in this example by setting up a plant operation scheme for a chilled water circuit employing 2 chillers. So the first thing I need to do is to add an additional chiller to the chilled water supply subloop. So I'll step down to the chilled water, the supply subloop of the chilled water loop. And I can now add a chiller by clicking on the Add Chiller tool, and I'll place the chiller to the left of the existing one. I'll now select the new chiller and edit it. I'm going to change the name of this chiller to Small Chiller. And I'm going to change the reference capacity to 30 kilowatts rather than allow it to be auto-sized. And I'll OK that. Now I'll edit the other chiller, and I'll change the name of this chiller to Large Chiller. And I'll change the reference capacity to 200 kilowatts. So now I need to connect the new chiller to the supply subloop. I'll first move the existing chiller over to the right to make some room for the new connections. I can do this by clicking on the Move Select Object tool, and then I can click back on the chiller to move it. I'll just move it over to the right a little and click the mouse to place it. I can then connect the new chiller up by clicking on the Add Connection tool, which is this is the universal connection tool that's used to connect all items of equipment up in DesignBuilder HVAC. So now if I move the cursor to the chiller flow outlet, you'll see a green connection marker appears when the cursor snaps to the outlet. I can then click the mouse button to attach a connection to the chiller flow outlet. HVAC connections are placed in the form of a number of segments or steps. Each segment automatically snaps to the X or Y axis. So in this case, I'm going to move the cursor until it's slightly below the outlet, and then click the mouse to place the first segment. I can then move the mouse over to the right until it's level with the mixer inlet, and you'll see that a vertical drawing guide automatically appears, which allows me to snap to the same X coordinate as the inlet. So I can just snap to that drawing guide and then move the cursor down to pick up the connection with the mixer inlet, and then just click the mouse to complete the connection. I'll now go through a similar process to connect the chiller inlet to the splitter. Okay, so I'll now move back up to the system level. To set up the plant operation scheme for the chilled water loop, I'll select the chilled water plant loop to edit it. And you'll see there are 2 tabs on this dialog. The first tab allows you to change the plant loop settings and sizing information, and the second tab allows you to set up the plant operations schemes. For this example, I'll only use one scheme which will operate all the time, and for this scheme I'll set up 2 ranges. So I'll click on the number of ranges and set it to 2. Then I'll set the upper limit for the first range to 20 kilowatts. And the then set the check the small chiller, to activate the small chiller for the lower range. This means that only the small chiller will run when the load is less than 20 kilowatts. Then I'll open the range 2 header and change the lower limit to 20 kilowatts to match the upper limit of the previous range. And the upper limit to a very large number, say 1,000 kilowatts. And then I'm going to check both the small and large chiller check boxes to activate both of these chillers if the load is above 20 kilowatts. Okay, so I can now return to the system level to connect up the plant and condenser loops. First of all, I'll go down to the demand subloop of the condenser loop, and I'll connect this up to the small chiller condenser using the connection tool as before. And then I'll connect the flow up to the large chiller. And now the return to the small chiller, and then another return to the large chiller. So that's connected the condenser loop up. Okay, I'll now go down to the chilled water loop demand side to connect it up with the air handling unit cooling coil using exactly the same process. And now I'll connect up the fan coil, cooling coil. Both the return and now the flow. Okay, to complete the connections, I'll now go to the hot water plant loop demand side. First I'll connect up the air handling unit heating coil. Okay. And now I'll connect up the fan coil unit heating coil. Then the VAV box heating coil. And lastly, the convector. Okay, I'll now go to the air loop demand side. Oh, that's not quite connected. There we go. I'll now go to the air loop demand side to connect it up to the zone equipment. First I'll connect the supply path to the VAV box without reheat. Now to the VAV box with reheat. Now I'll connect the return path to the extracts. First to the ground floor zones, and finally to the mid-floor zones. So that should complete the system, and I can now run an Energy Plus simulation. I should say that Energy Plus provides various report variables for specific HVAC components, but we haven't implemented access to these just yet, although this facility should be available when we introduce the new results processor with the released version of software. Anyway, because it's not possible to view the HVAC specific report variables yet, I'm not going to dwell too long on the simulation results. But just to demonstrate that we've created a valid system, I'll click on the simulation tab. It asks me if I want to go up to the building level to access data. I say yes. And I'm going to select a summer design week and hourly reporting intervals. Okay, so now I'll just run the simulation, which should only take a few seconds for a design week. Okay. So I'm going to select the 1 day per page option and the hourly reporting interval so that we can look at hourly variation in zone temperatures. If I now select the south zone on the ground floor from the navigator, we should see that during periods of high heat gain, for example, here around 10 to 11 o'clock in the morning, where mechanical cooling is required, that the set point is being maintained at 24 as required. Similarly, if I select the south zone for the mid-floor, we'll see a similar result, the set point of 24. And likewise for the top floor, which is conditioned by fan coil units, again you can see that the set point's being maintained. But I'm not going to go any further into the results. Really, the object of this exercise was to give you an idea of how you assemble an HVAC system in DesignBuilder HVAC. Okay, well that just about concludes the demonstration. We've only had time to scratch the surface, but hopefully it will have provided you with a starting point to do your own experimentation, and we'll look forward to any feedback that you can give us. So thanks for listening, and now I'm going to hand you over to Andy, who's going to give you a quick overview of the daylighting module.
Thanks, Steve. That was very interesting. I'm just getting my screen up now. Hopefully you can all see my screen now. I'm going to show you the latest daylighting calculations that we've been implementing recently. They're based on the Radiance calculation engine, and at the moment what they do is to generate daylight factor and illuminance contour plots. So I'm going to demonstrate it based on an existing model that was that we've got here. Essentially, the way that the calculations work is that you can use any existing DesignBuilder model. All of the data that's required as input to Radiance already exists in any DesignBuilder simulation model. So what we're talking about here is obviously the geometry, and actually the geometry that's used in Radiance is based on the same geometry that you see in the visualization screen, rather than the simplified geometry that's provided to Energy Plus. So you get all of the details of the dividers, the thickness of the walls, etc., etc. So yes, so the geometry is provided to Radiance. Also the surface reflectance data for each of the walls, floors, ceilings, etc. And the glazing transmission. So just a single transmission factor. Radiance is able to calculate transmittance for different incidence angles. The other bit of data that's also used is the site's ground reflectance value. So I'll show you, if I click on the daylighting tab at the bottom here. This is some data that's already been generated actually for the building. But I'll show you how that was generated. Normally, when there was no data available, the daylighting calculation options dialog will be shown. And from this you can select, I'll just go through the various options briefly. You can select a report type, so if you particularly want to generate a LEED, a BREEAM or a Green Star credit report, you can select the appropriate option here, and that will select the necessary working point height in the Radiance calculations. So I'll leave that there. But the level of detail can also be selected as a kind of a broad brush selection. So we've got these standard sort of templates that you can select from FAST, which runs through the calculations very quickly with a very simple single bounce of light around the building, to the high quality where the Radiance parameters are set up to the maximum practical values. So for the purposes of this demo, I'll use the FAST calculations so we can get some results on the screen quickly. The working plane height is obviously the height of the plane that we're going to use to display the contours in the results. You can define a margin around the outside of each zone, and by default DesignBuilder gives a 0.5 meter margin. That means basically that when DesignBuilder is calculating the average daylight factors for each zone, it will exclude the daylight factors and illuminance values around the edge of the building, and that's to exclude any space that's not particularly used or around the edge of the space. But you can set a value of 0 if you don't want to have a margin. You can also select the sky model to use. By default, if you want to calculate standard daylight factors, you'll use a CIE overcast sky with 10,000 lux on the horizontal plane. But there are various other clear sky options to select from, and also a uniform cloudy sky. We'll stick with the CIE overcast sky 10,000 lux option here. Now, when DesignBuilder generates the grids for the Radiance calculations, it applies two particular grid sizes. You can select the maximum grid size, which is the overall size of the grid. Excuse me. And but if you've got a fairly large grid in particular, you might want to specify a slightly smaller grid size to fill in some of the gaps where the large grid size can't cover the area that's specified in the daylighting factor calculations domain. I won't describe the advanced options here. These are parameters that are required by Radiance. We've got some documentation in the help on this. So if you want some particular details on what each of these parameters mean, you can find that in there. But you'll notice that when you select a different template, it's those values that change. So essentially, if you choose a high quality setting, then you get 3 bounces of light around the building, for example. So as I said before, we'll choose the fast setting, and because we're at building level here in the navigator, when I click OK, DesignBuilder is going to calculate daylight factors for the whole building. So the way it works internally is that DesignBuilder is now generating a RAD file for Radiance to read, which defines the entire geometry of the building. And then it loops through each of the zones and calculates the illuminance values and the daylight factors for each of the zones in turn, according to the grid that we set up. Now, because I selected the lead credits report option on the calculation dialog, that's what's being displayed now. But we can also select from a range of other different reports. We can choose a BREEAM credit report, Green Star, and also we can select a map for the entire building. So what happens here? This is the image that you saw originally. Essentially, what's going on here is that you've got a slice through the whole of the building, and it's based on a height of 3.25, which is actually the first floor of the building. And DesignBuilder selects any zones that have a working plane defined at this particular height, plus or minus 0.1 meters, which is the margin. So that's a nice quick way. Even if you've got a building defined with lots of different blocks, you can generate entire floor plan daylight factor plots for any particular working plane. So I can select here if I want to look at the daylight factors on the downstairs area of the building, then I can select that working plane. And these heights are set up by analysing the building geometry. Now, the 5.5 metre one is in the loft where there's no daylight, so that's not particularly interesting. I'll go back to the first floor results. We can display the same data at first floor, ground floor, and roof block levels as well. Or we can go down into individual zones, so I can click down into individual zones and see a bit more detail, larger plots of the actual zones. So you'll see around the edges of each of the building, each of the zones, there's a 0.5 metre margin. That's the margin that we specified. And obviously this is the grid, so you can see there's a number of squares in each of the zones, and for each of those squares there's a daylight factor value has been calculated. Now, because I chose a fast calculation option, you can see that there's quite a lot of noise in the results here, and there's a bit of interpolation has been used in that option as well. So although I specified a 0.1 metre grid, actually Radiance is fairly intelligent about the way that it approaches its gridding, and it can tell where the areas of rapidly changing daylight factor are over a floor plan profile, and it does extra calculations around those areas and less so in the areas where there's less changes like this. Right, I can also redo calculations at any particular part of the building, so I could actually go down into for example, in this zone here, I might be interested in zooming in a bit more on the results here and getting slightly more refined results. I think that's cell office 8. So yeah, so I can update the calculations here using a finer grid. So I'll do that. I'll choose a standard detail template and up the quality of the calculations, and I'll use a finer grid to generate the results. So this will recalculate the values just for this zone. The results that were calculated for all the other zones previously will remain. So that's quite quick as well. So if I now go back up to the first floor to look at the results, oops, I need to select the map option there. You can see that there's a finer grid has been applied in that zone to the other zones which have got a coarser grid applied. So, oh yes, I haven't shown you the user-defined scales yet. At the moment, the scale is set to user-defined, so the minimum value in the scale is 0 and the maximum value is 12. And the nice thing about that is that you can get a uniform scale right across the building. So the colours that are displayed for the first floor are consistent with the colours that are displayed for other areas of the building. But if I want to get a more clearly defined set of results for perhaps a darker area of the building, say in the staff room, here I can select the zones to be to define the limits of the scale, and now you can see that the maximum daylight factor is about 2, and the minimum is 0. And that gives me more detail. Because we've used a fairly coarse calculation setting, the results don't look too great there, but you get the idea of, I expect, how it's meant to work. I'll just briefly touch on the different reports here as well. We're going to add some new reports. This lead report here is for lead 2, and we're going to hopefully implement the lead 3 equivalent report, which is more complex, hopefully in time for the version 2 release at the end of July. So basically, this loops through all of the zones, and the average daylight factor and the thresholds are calculated for each of the zones, and then the percentage above the threshold for each zone is added up, and then a value for the whole building is stored. So, so in this building, for example, you can see the total floor area is 172 square meters, and the percentage of the working plane for the whole building that's above the threshold, and the threshold is 2% daylight factor, is only 15.7, so it's not a particularly well daylit building. So the designers may need to get back to the drawing board. Anyway, hopefully that's given you a reasonable overview of the daylight calculations, and also for the HVAC calculations that Steve demonstrated. We can answer any questions that anyone's got now. I think we'll try and do it by text, or we were going to try and do it by text. I'm not sure whether people want to try and do it by voice instead. Perhaps we could try doing it by voice and see how that goes. So I'll unmute everyone, if that's possible. This may cause too much noise coming through, so if that does, then we'll just go back to text questions. If anyone's got any questions, please feel free to ask. Actually, it's really quite fuzzy, the sound, so I'm going to mute everyone again. And but please feel free to ask your questions, and Steve and I will do our best to answer them. We've had a couple of questions asking whether the new HVAC can handle more than one air handling unit, because that's obviously been a bit of a restriction in previous versions.
Yeah.
The answer is yes.
Yeah, there's no limit to that.
Yeah. And there's also a question about whether we can export the .rad and oct files from Radiance. You certainly can. I mean, they're left behind in the Radiance folder. But there's also a file export option here where you can export the Radiance model. I think actually that just exports the RAD file, but no doubt if the oct file is of use, that could be done as well. Oh yes, thanks Paul for that question about the way that reflectances are picked up. That's absolutely right. They're picked up from the materials. So I'll show you now how that works. I'm not sure if my GoToWebinar screen is hiding your view, but I'll move it over to the right here. Anyway, so for example, if we wanted to edit the reflectance of the external walls, we can open up the external wall dialog, and for the innermost layer, the material there is gypsum plastering. So we can enter we can edit the material data for that on the surface properties. The visible absorbance value there is 0.5. Well, the visible reflectance is 1 minus that. So if I enter a different value there, that will affect the reflectance that's applied in the radiance calculations. People are asking about documentation, and that's being developed at the moment. I know Steve's busy working on that at the moment.
Yeah.
When do you expect to have the first version ready, Steve?
I'm just replying to a question via text, actually, concerning that. But
Okay.
yeah, it's work in progress, and you know, it's not going to be before the end of the summer, really.
Okay. Yeah, there's a question about whether we can export a DWG file of the HVAC layout, and that's not possible at the moment. I mean, if we get a strong demand for that, then maybe we can consider implementing it, but we haven't got that implemented at the moment. In answer to the question about whether heat recovery and economizers are possible, yes, that's. I think Steve may have shown that briefly. They're defined at the air handling unit level. I think that's right, Steve, isn't it?
Yes, that's right. Yeah, all of the economizers that are available through Energy Plus are available through DesignBuilder HVAC.
Yeah. Diego Barra is asking about the export data and whether we also export PTS bars. I'm afraid I don't even know what they are. So we may need to correspond privately about that. And
is that a daylighting question, or?
Yes, it is.
Yeah.
Yes. And likewise with DASIM, I suspect there's probably not an awful amount more work to do on that, but I think we need to look into that as a separate project, because we haven't done any work on DASIM integration at this stage.
There's a question here asking if there's a chill beam template available. There are chill ceilings as well as cool beams. So there's a cool beam air distribution unit that you can add to a zone that can be connected up to an air loop and a chilled water plant loop. And then there's a chill ceiling that you can connect up to a chilled water loop.
So it covers all of the radiant slab options, I think, that Energy Plus provides. Is that right, Steve?
It does, yeah.
Yeah. But I've noticed there's a question about displacement ventilation, and that's not implemented yet. Although I suspect it's probably fairly high on the list of what we would like to do in the future. Okay, well, I think, should we call it a day there? And I'm sorry if we haven't answered all of your questions, but please feel free to send them in by email. We'll be making this webinar publicly available on our website, assuming the recordings worked okay. And so it'll be there. If you missed any of it, don't worry, hopefully that'll be okay. But if you've got any more questions, send us an email or get in touch whatever other way, and we'll try and answer them. So thank you everyone for attending. Also, I'm sorry we weren't able to discuss stuff like availability, prices, etc. Again, we'll do that through a separate mechanism. Send us some emails and we'll talk about some of those details as well. So thank you all for attending, and well, I hope to see you again soon.
Yes. Okay, thanks and goodbye.